Next, we need to define variables. The definition of variable is very similar to those we have introduced in tutorial 1. This is a syntax. From this syntax, we can see the only difference is that we need to provide the index list. This index list will provide the domain of this variable. If the variable is 0 dimension, then we don't need to provide index list. As we mentioned in GAMS tutorial 1, there are 5 variable types. They are free variables, positive variables, negative variables, binary variables, and integer variables. Now, let's go to GAMS to define variables with at least one dimension. In this mathematical formulation, all variables should be non-negative. That means the variable should be from 0 to positive infinity. So we use the keyword positive variable or positive variables to declare them. Let's use positive variables. In the mathematical formulation, we only have variable x. We provide the variable name and the index. The variable is defined over the set I and j. Index I and j should be separated by comma. After we finish, we should add semicolon. Next is to declare the equations. The declaration of equations is very similar to what we have introduced in GAMS tutorial 1. Let's go back to GAMS and declare equations in the mathematical formulation. When we declare equations, we use the keyword equation or equations. Let's use equations. And we provide the name of the equations. We have 2 constraints: maximum productivity constraints and demand constraints. We use the name max CAP to denote the maximum productivity. After that, we provide the index list. These constraints are defined over the set I. So then we provide the index I. We use the name demand for the demand constraints and then provide the index. Because these constraints are defined over set j, so we provide index j. Then we finish the declaration of equations. We need to use semicolon. After that, we need to define equations. As we mentioned in GAMS tutorial 1, the declaration of equations and the definition of equations should be in separate statements. The definition of equations is also very similar to what we have introduced in GAMS tutorials 1. The only difference is also the index list. We need to provide the index list for each equation. Let's go back to GAMS and define those equations in the mathematical formulation. Now we define equations. It starts with equation name, max CAP, the equation name, and the index list. After that is 2 dots. And we need to write summation j, all elements from set j. This is the summation operator. How can we use summation operator in GAMS? Before we go back to GAMS to define equations, we also need to introduce arithmetic operations, index operations, and functions in GAMS. This is because when we define equations in GAMS, we need to use arithmetic operations. Also, we also need to perform index operations, and sometimes we also need to use some mathematical functions when we define equations. Let's see the standard arithmetical operations. In an equation, if there is an exponentiation, then we should use this symbol. For instance, the y power of x can be written as this term in GAMS. If there is a multiplication, then we should use this symbol. If there is a division, then we should use this symbol. If there is an addition, then we should use this symbol. If there is a subtraction, then we should use this symbol. If we want to use this term to denote the y power of x, this operation is not defined if x has a negative value. That means x should be non-negative. As we use index list in an equation, then in some cases there are indexed operations. It starts with the keyword for index operation and then two brackets and then index list. After that is comma, and then we can write the expression. The index operation in GAMS includes summation, product, minimum value, and maximum value. The keyword for summation is SUM. The keyword for product is PROD. The keyword for minimum value SMIN. The keyword for maximum value is SMX. The index list can be one index or multiple indices. If we have multiple indices, then we should use bracket to include them, like this. If we have two indices ij, then we should use bracket to include these two indices. The indices are separated by using comma. Let's see some examples to show you how to do the index operations in GAMS. If we have summation in an equation, summation j xij for instance, then we can write the SUM, use the keyword for summation and then two brackets. Then we write, because we summation j, the index j, so we write index j here and the comma, then we write the expression xij. If we have summation j and summation I in an equation, then we use the keyword sum, then brackets. We first summation the index j, and then we summation the index I, then we write the expression. We can also use sum and include the two indices I and j together, then we write the expression. Both of them are the same. If we have the product, then we can use the keyword prod, then two brackets, then the index, comma, then the expression. Here, there is one example to use summation to directly assign values to a parameter. If we want to find the largest value or smallest value over the domain of the index set, then we can use SMax operation and SMinimum, SMin operations. We start from the keyword SMax, then brackets. Then in the brackets, we give the index list. In this example, we want to find the maximum capacity over the domain of I and M. So that's why we have the index list I and M here. Then we write the expression. In this example, for each index I, we want to find the minimum value of D over the domain of J. Then we use the keyword SM. Then the index here, we only use the index J. Don't include the index I because we want to find for an element from a set I, we want to find the minimum value of D over all J. For instance, if D represents the distance and I represents the plants, the J represents the markets, then this means what? Then this means for each plant, we want to find the minimum distance from this plant to the market. For instance, if I is equal to Seattle, then that means we want to find the minimum distance from Seattle to a market. In an equation, we may also use some mathematical functions like absolute value, so then we can use ABS function. If exponential of x, then we can use exp. If the function is natural logarithm, then we can use log x. If the logarithm base is 10, then we can use log 10. If the logarithm base is 2, then we can use 2 log 2. Square root of x is sqrtx. Square of x, we can use the function sqrx. Then we can use power xy to return the y's power of x, but y must be integer. We can also use exponentiation operator 2 star. As we introduced before, if x is a non-negative value. In other words, we can also express as x 2 star y. We can also use the function max and minimum in to find the maximum value of and the minimum value of the arguments. This maximum and minimum function is different from the S max and S min index operator. In this max and minimum function, we don't involve any index. Based on this, then we can define equations. As we mentioned, the difference from what we have introduced in GAMS tutorial 1 is the index list. Okay, let's go back to GAMS and define equations in the mathematical formulation. In the mathematical formulation, we have two equations, maximum capacity constraints and demand constraints. So we define maximum capacity constraints. We put the name AAP of this equation. Then we have the index list. After that, we need to have 2 dots. Don't forget these 2 dots. Then we write the expression on the left-hand side. The expression on the left-hand side is a summation index operation. So we have summation brackets. Then we provide the index list. This summation is over j. Then comma, and then we write the expression. This should be x ij. Then we should define the type of the equation. It should be less than or equal to. So we should use less than or equal to sign, this sign in GAMS. Then the right-hand side of this equation is the maximum productivity. We write AI. After we finish that, we should add semicolon. Next, we define the demand equations. We give the name demand index list J. This equation is defined over the domain of J. Then two dots. Then we write on the left-hand side of this equation summation brackets. Then next is index list. The index list should be only I. Then we write the expression xij. The type of this equation should be greater than or equal to. So we use the sign greater than or equal to in GAMS. Then the right-hand side of this equation is the demand of each market. Use Bj. When we finish, then we add semicolon. We finish the definition of equations in the mathematical formulation. Next, we need to define the object function. The definition of the object function is very similar to what we have introduced in GAMS tutorials 1. As we mentioned in GAMS tutorial 1, we cannot directly input the object function into GAMS. We need to define a free variable and use that free variable to denote the object function. That means we let that free variable to equal to the object function. Then we convert the object function into equations. Then we can input the object function into GAMS, which is similar to input the equations. First, we need to define a free variable. How do we define free variable? We use the keyword variable or variables, right? Let's use variable. Then we give the name of the free variable. Let's define z. Then we finish. We should add semicolon. Then we let this state to be equal to the object function. Then we can define this object function like an equation. We first need to declare this equation. This is object function. We give the name obj. As we mentioned before, the object function should be 0 dimension. So we don't need to add any index list. After we declare the object function, we need to define the object function. The name of the object function is obj as we declared. Then two dots. The left-hand side of this equation is z. The type of this equation is equal, so we use the equal sign in GAMS. And then the right-hand side is the object function we write in the mathematical formulation. That should be summation. We use the sum, then brackets, then we summation I and j. So we have two indices. We need to use bracket. Then we have comma. Then we define f times tij times xij. Then we finish. Then we add semicolon. Then we finish the definition of the object function. Next, we need to define the model, very similar to what we have introduced before in GAMS tutorial 1. We use the keyword model, then provide the name of the model, transportation, then two slash. Within these two slash, we need to provide the constraints. Because we want to include all constraints, we can use all. If we don't want to use all, then we can list the name of all equations. Max CP count obj. Here, we just provide the name of those equations. The index list cannot be included. After we define the model, then use semicolon to finish this statement. Next, we need to solve the model. We use the keyword solve. Solve the model name transportation using, so this model is LP model, so we're using LP. The objective is to minimize the total transportation cost, so use the keyword minimizing. The free variable we define to denote the value of the object function. Then we finish the solve statement, use the semicolon. After we solve the model, we need to display the results. We use the display statement starting from the keyword display. When we display the variable, we should have variable name, dot, and suffix, dot L. This means to display the value, the optimal value of variable x. We also want to display the value of the object function. Then we display the name of the variable, dot L. When we finish it, add semicolon. Next, we can run this code. Let's click run. Then we find some errors. When we try to fix errors, we should always try to fix the first error. Let's see the first error, unknown symbol. Unknown symbol is here. We found that the model name in the solve statement is wrong, so we need to fix that. Then we save, then we solve it again. You can see, and then we fix all errors. Then GAMS provides the value, the optimal value. Let's go to the list file. We close this log file. Then we click here, and then we can get the list file. Then from the solve variable, we can see the optimal value. This is the optimal values for variables. We can also see them from the display statement. Here, this is the optimal value for the variables. Then this is the optimal objective value. We can go to the solve summary. Then you can see the model status is 1. It shows optimal. That means we actually get the optimal solution. And we have 6 equations and 7 variables. The 7 variables, we define 6 variables to note the amount of products that are shipped from a plant to a market. Also, we define a free variable z, denote the value of the object function. So we have total 7 variables. Why we have 6 equations? We have 2 equations for the maximum capacity, 3 equations for the demand, and 1 equation for the object function. From the resource usage, you can see CPU time that is used to solve this model. It is 0.017 seconds, very small. Then we finish all the GAMS code for this example.